Given that sec x equals square root 5 and 90 degrees, x is between 90 and 360, find the exact value of cot x. There's so many different ways of doing this question. I will show you one to start off with, and I'll see how I feel. I might show you the second as well. If I have the sec of x equals square root 5, I can change that and say, well, the sec of x is the same as the cos of x in the inverse, so 1 over square root 5. Okay, then I can go, it all depends if they say with or without the use of a calculator. If they say find exact values, well, I can still do it. If I say the cos of x is 1 to square root 5, and I draw my cos diagram over here, cos is positive in my first quadrant and my fourth quadrant. But they say that x lies between 90 and 360, so this cannot be the answer, so this must be the answer. Which means that if I make my triangle in this direction, the cos of x, if this is x, cos is 1 over square root 5, 1 is adjacent, this is another color so you can see it, so cos is adjacent over hypotenuse, so it means it's 1 over square root 5. Now I can calculate this side, this, let's call it y. I can calculate that y by using Pythagoras. I can say y equals the square root of square root 5 squared, which is 5, minus, because I'm subtracting, this is the hypotenuse, minus 1 squared, which is 1. 5 minus 1 is 4. 5 square root of 4 equals 2. Y equals 2, but it's underneath the line, so y actually equals negative 2. If I have that negative 2, I can now calculate what cot x is. I can say tan x equals, now tan x is opposite over hypotenuse, minus 2 over 1. Therefore, the cot of x equals the inverse minus 1 over 2. And that is my answer. If I want to calculate what is the cosec of x, I can just say, well, the sine of x, in this case, their sine x is negative 2 over square root 5, negative opposite over hypotenuse, so negative 2 over square root 5. Therefore, the cosec of x equals the inverse negative square root 5, or not the inverse, the reciprocal, minus 5 over square root 2. There's an answer, there's an answer. The other way that you can do it is, first of all, you can still do your cos diagram. You can still say, so let's do this in blue. This is just method number 2. Some of you might find that this is easier. It all depends on you. So sec x equals square root 5. Sec is the same as cos, is the same values as cos. Therefore, it's going to be positive in my first and fourth quadrant, there and there. If I say cast, but it needs to be in there, so it cannot be that one. Same thing as we've done, we just don't use values. I'm then going to use my Pythagorean theorem. If sec x is square root 5, then sec square x will equal 5. I also know that according to my Pythagorean theorems, tan x square equals sec square of x, which means tan square of x equals, subtract 1 on both sides, sec square is 5, that's where that 5 comes from, it comes from there. 1 goes the other side, becomes 1. It means that tan x equals 5 minus 1 is 4, but I have to take the square root. If I take the square root as plus minus, therefore tan x is plus minus 2. But cast can only be, tan is in my fourth quadrant, negative, therefore tan x equals negative 2. Therefore, cot x equals the inverse of that. Now remember, that's actually minus 2 over 1, so the inverse of that, or the reciprocal of that, is negative 1 over 2. Same answers there, just a lot of words. So I might ask, solve this using the Pythagorean identities, or I can say without the use of a calculator, and that is then what you work towards. You can also do the cosec x by using your Pythagorean identities and using something like 1 over that cot square, cot square of x plus 1 equals cosec square of x. Now we have cot square, so it means that this will be -1/2 squared plus 1 will give me cosec square. That will give us quite a big value. That will give us 1/4 plus 5 plus 4/4, which equals the cosec square of x. That means that the cosec square of x equals 5/4. Take square roots both sides, therefore cosec x equals square root 5/2. Also have to remember that in my fourth quadrant, cosec is the same as sine, so it's going to be negative. I still find this way much easier.